In this video, we're going to talk about what makes a graph good and what makes a graph less good. So the point of graphs is to communicate information about data. And we encode that information in particular visual features, right? Like we encode the shape of a continuous variable as the heights of bins, right? The bars in a histogram. But some visual arrangements of shapes or patterns or features are more intuitive for our brains to understand, or our brains like to interpret them in a particular way. And so if we choose a less optimal way of communicating information, it can be harder for us to detect the key information the graph is trying to convey. And if we choose an arrangement that implies something that is different to what the data actually show, then that graph can be misleading. Here's one example of a real graph showing the number of gun deaths in Florida after a law was passed in 2005 called Stand Your Ground. And so this graphic here is plotting the number of gun deaths in Florida over time. And we can see we get to this point here, 2005, and then the line goes down, right? The number of gun deaths, the line indicating the number of gun deaths goes down. So typically when something goes down, we think it's decreasing, right? So this graph at a first quick glance might suggest that the number of deaths is increasing after this law is passed. However, when they created this graph, they chose to plot the y-axis in the opposite direction to normal, right? So actually, as we go down the y-axis, the number of deaths is increasing, which is counterintuitive because we normally expect the opposite pattern. So actually, the number of deaths was increasing after this law was passed, but we have to look extra carefully at the graph to come away with that takeaway. Here's another example. So this is a graph showing average global temperature. This was published by a magazine, and the graph appears to show that actually global temperatures haven't really changed for the past century or so. However, one thing we'll notice is that it shows the temperature range all the way from -10 all the way up to 110, even though the range of data is only really somewhere between 55 and 60. So even if there is some change in there, the fact that we're showing a much greater range will cause the line to look flat. And actually, when you do that, when you show just the range of temperatures that are actually changing, and this is in Celsius rather than Fahrenheit, then we can see that there's a much more obvious upwards trend over the same time frame, right, over the past 140 years. So this just goes to show how design choices, right, how you choose to convey the information in the graph can influence its meaning, right? You can distort the trend as the first graph did by making it seem like there wasn't much of a change. Whereas, as we can see from this second graph, there's clearly a pattern. So here are a few principles to think about as you go about creating visualizations. The first thing is to be honest, right? Make sure that you're not trying to mislead with your graph and convey an interpretation of the data that is not really that. Second is to be clear, right? Make sure you choose types of graphs that accurately convey the, the trends in the data. And third, don't mislead. So make sure you show all the data, including outliers, everything that's a valid measurement. And don't break conventions, right? As we saw in that Florida gun deaths graph, right, which sort of flipped the y-axis. Don't break conventions if at all possible. And if you do so, you need to be extremely upfront about it. Finally, if you do leave something out of a visualization, that's something else you should be upfront about, and you need to have a good justification for doing so.